Hello and welcome to this edition of Room 2003 Science. We are doing a little video this morning for physical science that has to do with writing atom and ion notation from atom model drawings. So we're going to be given atom model drawings and we are going to learn how to write atom and ion notation from them. Before we begin, I want you to do a quick speed review because these questions that are coming up are just foundational to what we're doing. And the questions are, what are the three subatomic particles? Where is each one located within an atom or ion? What are their relative sizes? What are their net charges? Pause the video for a moment and think about or jot your answers down to these three questions and then unpause and proceed. So you're back. You have your answers to those four questions. I think I may have said three questions previously. But the first answer, what are the three subatomic particles? They are the proton, electron, and neutron in no particular order, but those are the three. Where is each one located within an atom or ion? Protons and neutrons lie within the nucleus, and electrons lie within the space outside the nucleus that we refer to as the cloud or electron cloud. What are their relative sizes? Well, neutrons and protons are about the same size, and they are much, much bigger than electrons. What are their net charges? The neutron, we say, has no net charge, or we say is neutral, or we say is zero. The electron, negative net charge, or negative symbol, not minus symbol, negative symbol, and the proton, positive net charge, or simply positive, or the positive symbol, not the plus symbol, positive symbol. So back to the task at hand, which is being able to write atom or ion notations. When you're done with this video and with the follow-up practice, you will be able to write the notation for any atom or ion given the necessary subatomic particle data. There is a minimum amount of data you have to have, and that is either given in a problem or description or a drawing. So what is an atom or ion notation? What it is a concise way to document and communicate the subatomic particles within an atom or ion. So in this symbol, with this symbol, I know how many protons, how many neutrons, how many electrons are in this atom or ion, and I know where to find the atom information about it on the periodic table. So I have a couple slides here that review Z, A, and net charge. And we've covered this information previously, so in the interest of the amount of time for this video and the processing time that relates to, I provide the slides so that you can go back and look at the info, but we're not going to go over them. So I'm going to click to each slide and just pause for about 3 to 5 seconds. And that way you can pause the video and have a chance to look at those if you need to or if you desire to. So here we go. Z. A. Net charge. A little follow-up on net charge. And back to atom and ion notation. I want to start with an example from my personal favorite atom element, and that is Einsteinium. In the first example, we have the notation for an Einsteinium atom. How do I know that? Because here at the net charge sets a 0, and we don't have to write the 0 when that is what the net charge is. If you don't see anything, it's implied that it's 0, but I like to see it just to know that we've thought it through. And then here is the ion that Einsteinium would be anticipated to form. Um, same base in terms of the Z and A, but now our net charge has gone to +2. Not +2, +2. All right, so how do we write atom or ion notations? Here are the steps, and they're fairly straightforward. Again, we have to have a certain amount of information on hand. First, we gather the subatomic particle data. And I've got this little form that I like to use and that I've encouraged you to use. But if I can fill this form out, then I have everything I need to write the notations. So gather subatomic particle data, get the periodic table or internet. So once I have this, I will need either the periodic table or I can use this information to look up element symbol on the internet. Fill in any data table gaps. So given certain combinations of these, I don't need all these given, but given certain combinations, I can fill in every blank. And then step 4, write the symbol. So gather data, get the periodic table or internet, fill in any data gaps, and write the symbol. So let's use as an example, problem number 1, which we did last week. And it's a drawing. These problems are going to deal with drawings. We will deal with other non-drawing problems in a follow-up exercise. But what do I know about this atom or ion based on the drawing? Well, number of P, I can count them up. They are represented by this positive symbol charge. There are 3 of them. I can know the number of N because of the drawing. The neutrons are represented by the open circles without any charge symbol. There are 3 of them. And I can know the number of E because it is represented by the negative symbol negative symbol inside the circle here. There's 1 of those. Well, by knowing these, I can fill in quite a bit of this down here. Because I know P, and going back to the review slide, I know that P and Z are equal, so Z equals 3. Because I know P and N, the number of protons plus the number of neutrons is the A, I know that A is equal to 6. And because I know the E, I can get the net charge. How do I do that? Again, based on the review slide, I take the difference between the number of P and number of E. So 3 minus 1 is 2. And then for the charge sign, it's positive because there are more P than E. So again, the difference is between 3 and 1 is 2, and the sign is going to be positive because there are more protons, more positive charges. So the net charge is +2. That only leaves this blank here. And if you'll remember from the data form, the element symbol goes here. This is where I need the periodic table or the internet. So with the periodic table, what I need to know is either the number of protons or the Z or the atomic number. Remember, all these are equal. And for our problem at hand, the value is 3. And here is 3 on the periodic table. So I know that the element, sorry for the phone ring, I know that the element is lithium and the element symbol is Li. So I add that in here. Now, with this information, I am ready to write the element symbol, element notation, atom notation, or ion notation. In this case, it's an ion. So we start with the element symbol, Li, and then this is just my habit. I write the Z in next. Remember, Z goes down here lower left, and then the A upper left, and then the net charge. And there we have it. In this case, again, it's an ion because this is not 0. If this were 0, it would be an atom, but it is not. It's +2. That means that this is a lithium cation. And here is the notation for it. All right, that's our example. And remember that we completed problem number 2 previously as well. So the new problem set begins with problem number 3. I didn't want you to think that I had missed one, or I didn't want that to be a sticking point. So we have problem number 3, 4, 5, 6, and 7. You have 5 practice problems. Please back up to any point in this video that you need to figure those out, and we will get back together and review your atom or ion notations together. That's it for now. Until next time, be well and be safe.